seen by the human eye. Of all the colors, blue light has a very short wavelength, which means it produces higher amounts of energy. Studies suggest that over time, exposure to blue light can cause serious long-term damage to the eye, such as digital eye strain. This temporary discomfort can encompass a range of ocular and visual symptoms. Estimates suggest its prevalence may be 50% or more among computer users. Symptoms may include dry eyes and redness, headaches, increased light sensitivity, and blurred vision.
Our eyes allow us to detect different patterns of light which are converted into images by the brain, giving us the ability to see the objects around us. So let's briefly look at this process. Light rays bounce off objects around us and towards the eye. Light first enters the cornea, which is a clear portion of the eye. Then the light passes through a small opening called the pupil. The color region of the eye, called the iris, controls how wide the pupil is and how much light can enter the eye. The lens then focuses the incoming light at a region on the back of the eye, called the retina. The retina has over 130 million cells which are sensitive to light, known as photoreceptors. Now this is where the light information is converted into electrical impulses, which are then passed on to the brain through the optic nerve. The brain processes the incoming information into images and helps us see the world around us.
Light causes damage to the retina and decreases photoreceptor responses to light. The most harmful component of visible light is the blue wavelength, which ranges from 400 to 500 nanometers. Our eyes are exposed for a very long time to high levels of blue light on a daily basis. This includes screens, artificial LEDs, neons, etc., so it is important to find ways to reduce their detrimental impact on the eyes. A study examined the usefulness of blue light filters when exposed to high intensity. They examined 3 groups of mice. One group was not exposed to any light, Group 2 was exposed to high intensity visible light, and Group 3 exposed to the same light as Group 2 while also being protected by a blue light filter. The researchers reported better overall retinal structure and greater photoreceptor survival in mice that were protected with the filter. In addition to the effects of prolonged exposure to blue light, the distance between your eyes and the digital screen can have an effect on the severity of the symptoms. There are many ways to prevent the progression of damaging effects by blue light and excessive digital screen use. Firstly, try reducing or limiting daily screen time. Also consider using blue light filters on your computer screen or enable the night mode feature on your phone. Make sure to keep a proper distance between your eyes and the screen, and make sure to take frequent breaks during screen use. And when using a digital screen, ensure that the light is not too bright and does not produce excessive glare